Hello everyone, my name is Viraj and today we'll be looking at the 7th problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here and I have ticked off the 800 rated parameter. I'll find my 7th problem, don't try to count. Let's open this up. Alright, so I'll read the problem. Given a string x of length n and a string s of length m, where n into m is together as a product less than equal to 25, consisting of lowercase Latin letters, that is basically A to Z, you can apply any number of operations to the string x. So there is an operation they're talking about. Now what is that operation? In one operation, you append the current value of x to the end of string x, and note that the value of x will change after this. So this is very important. All right. So they have given you a small example also. If let's say x is ABA and then after applying the operation, ABA changes to ABA and then again ABA, because you basically have appended x to itself, and then so on if you append it once more. So this is basically one operation that you are doing of this appending thing, right? Now after what minimum number of operations, s will appear in x as a substring. A substring of a string is defined as a continuous segment of it. Alright, so we have read the problem. Let's try to generalize this and understand what are they asking. Okay, so they are saying that you have been given a string x, alright, and a string s. Now this string is of total length n and this is of total length m. So let's take an example. Let's say x is Viraj. Now what will happen is, if you say you have done one operation on this, this operation is basically saying append x to itself. Append x to itself. This is one operation. So what will happen is, if let's say I do one operation on this, this string now becomes Viraj and then Viraj again, because you basically have appended the initial string x one time at the back. Now there is a new modification and the string x has changed. It is no longer Viraj. It's now Viraj and Viraj together. So there's basically 2 times Viraj. Now if I do one more operation this, x will modify by saying I have the initial string Viraj and Viraj together. So basically 2 times Viraj. This is x actually. And now you appended it as an appended x to itself. So you will append Viraj and Viraj again to this. Alright, so that is the case. That is the operation basically. You want to append x to itself and then store and keep that x also. Basically, if x changes in after one operation, you use that new x to modify again and again and again and again. Alright, so this x is basically given. Now again, I've taken just an example string of my name. You can take any sample string to understand this. They have obviously shown you a very simple example with ABA, and I think it should be very clear from this statement only. As the same logic, ABA gets appended, ABA and then ABA again. So basically this 6th lengthed string has now been created, and if you now do one more operation in this ABA together gets appended at the very end. So now you have a 12 lengthed string actually, which is initially this ABA and then at the very end also ABA. So you are basically trying to append and then save it also, and then utilize that string later to append it to itself. You don't want to start from the main string or the very initial string again. It is definitely getting modified every time. Alright, it's a very, very basic thing we have to take into picture. Now, of course, this is happening. What do we actually want? We want to say that this number of operation that I'm utilizing to do, I'm doing one operation, this is count 1. Then I'm doing one more operation, this is count 2. When I'm doing these operations, I am trying to check after how many minimum number of operations do I feel s is actually visible in the new string x. Okay, so this might be confusing. X is the string that we are appending together and together, and this string s, that is of the m length, s for, you can say, ship, I want this to be visible in the string x. So just for example, let's say that s was a string that looks like AGV. If this was the string, then you can say very well that initially when I had this x Viraj, it was not visible. But now when I did one operation my new string looked like Viraj. Over here I can see AGV as a substring that is coming over here. So for the answer for this particular query, piece of query where X is Viraj and S is AGV, in this case the answer becomes 1. Because only after one operation I am able to find S as a substring in the string X. S as a substring in the string X. So I'll write this down. S as substring in X. Alright. So this is my target. I want the minimum number of operations. Minimum operations. Alright. So now I have understood what the problem is trying to ask me. Let us look at some test cases and see how are they solving it, as in what argument are they giving for any answer, and we'll just cross verify with that in our mind. So let's say we'll talk about the first case. They have said the string X was A and then the string S was 5 times A. So let's copy this down. I basically have X equals to A and then S is equal to A. Now in this case, I can see that if let's say I do X equals to A and do one operation in this, X will become double A. Now if I do one more operation in this, this becomes 4 times A. And then now if I do one more operation in this, this becomes basically 8 times A. 1, 2, 3, 4, 5, 6, 7, 8. And in this, I can see that if I take up, let's say, this portion only, this is definitely a 5-lengthed substring, which is actually S, because S is 5 times A. So 5 times A was not coming over here. It was not coming over here. It was not coming over here. But at this location, it actually popped up. I can take up this string, maybe, or this substring. It's there. And because it's there, I know the minimum number of operations I took to actually make that visible is 3. Hence, the answer to this test case turns out to be 3. We can see, I think, yeah, the answer is 3. So you can actually manually solve other cases and you will find that the answer checks out. All right. So we have discussed the problem statement. We have discussed the sample cases. Now we'll try to understand, first of all, before even creating an idea, how and where do we actually want our logic to run in terms of time complexity. Correct? I need an expected solution in my mind to figure out, okay, this is the upper limit I want to go. So let's discuss that part. Now, elementarily, I know that 1 second allows me 10 power 8 elementary operations. This is a fact. I know this part. Now, I have been given per test 2 seconds. For 2 seconds, that means I get 2 into 10 power 8 operations, elementary operations. And this is basically I'm getting for per test. Now, in every test, there are some test cases. So it's written very clearly that every test basically contains T test cases, and test cases are highest in 10 power 4 order. So if I ask you that how many number of operations, elementary operations, are you given or capable to do for every test case, then that would be that, okay, in 2 seconds, I basically want 2 into 10 power 8 operations. This is for per test. And in one test, I have 10 power 4 maximum test cases. That means this is 2 into 10 power 4 elementary operations. Now I know that this is the number of elementary operations I can do for each test case. And now if I know that this is the highest limit I can go, if I ask myself, how or where do I want my time complexity to fit, we can actually argue in that order. We have n into m with us. So n into m together as a product is 25. All right. So 25 is pretty small. Correct. 25 is not very large. That means if let's say I have 2 into 10 power 4 order revealed, that is 1, this is like 1, 0, 1, 0, 1, 0, 1, 0. So basically 20,000 operations that are available to me to do. So maybe I know that I can run a complexity up to 25 into 10 power. If I do this as 2 order, then I'll be good to go. I cannot go into 25 into 10 power 3 order, because that would basically mean I am going in 25,000 operations. I don't want to go that, because the highest limit I know is 20,000. So I basically have a solution that is 25 into 10 power 2. So now if let's say I write this down in a very general case, I have something like O of n into m into 10 power 2 or anything below this. So if I let's say create a solution that is O of n into m into 10, or let's say I create O of n into m into let's say 5, or let's say you can create anything below this, maybe you go even up to a constant time limit, then you are good to go. But I cannot go above this. So I know now in my head what is the expected time complexity. The expected time complexity looks in this order. I don't want to go anywhere above this thing. This is the expected time complexity. All right. So now let's actually go to our discussion part and try to understand how can we create a solution. All right. We have discussed the expected time complexity. I know I don't want to go above this thing. If I go above this thing, I obviously get a TLE. So let's try to think how can I form a solution that is within this boundary. So again, the first question to ask myself is, since I'm appending x to itself every time, is that going to happen in an infinite order? Like, is there some place where I know I can stop? That's actually a very important question. So I'll ask myself, where do I stop? Or where do I finally say this is the end? What do I mean by this? So you have a string x and you modify it to become x plus x. Then you modify it to become, let's say this x plus x is, let's say x dash. So you become x dash plus x dash. Then you make it, let's say this is x double dash. So you make it something like x double dash plus x double dash, and so on, so on, so on. And does this go to infinity? The question is this. No, I actually am stopping somewhere. There is some upper bound where I have to stop, if you think about this. And the argument is yes. To be very specific, the argument is I cannot, or I don't need to go above 5 operations. So the argument is should not go above 5 operations. Now the argument, since I have written this down, let's try to think why. Okay, I'll start. Let's say you have n into m that's given equals to 25. Now remember, n is the length of x and m is the length of s which you're trying to find. What is the worst case which can happen? The worst case can be, let's say you have n to be very small, as in n can be maximum small 1. And then the m is very, very large. The highest m you can actually go is 25. So this creates 1 into 25 order. Now for 1 into 25 order, this total gives you a product of 25, so you're good to go. But now what problem does this create for you? X is so small that it's just a single letter. So just let's take an example like this. Let's say X is a letter. Let's say this letter is A. And let's say string S is actually the letter A 25 times. This is basically 25 times. 25 times. So you're trying to create S in X. But X currently is a single letter A. So you will of course have to append. Because you know that X dot size is currently smaller than S dot size. Till this condition is true, till then you can never find S within X. So I know I need to do one operation. So I'll do one operation on this. And now X will become 2 times A. But now still S is not visible. So what will you say? You will say, okay, let's do one more time. And I'm going to make X go from this 1, 2, 3, 4. But still, you know the size of this is 4. 4 is eventually, of course, not going to create a string that is of 25 size. So you will do one more operation. This basically creates 8 times of X. This is like 8 times. And then again, you create something that is like 16 times. And then finally you create, after one more operation, an X which is obviously of 32 times A. And in this 32 times of A, of course, you will find a substring that is 25 A's. That is basically the string S. And you will say, yes, I found it. I'm good to go. Now what is the number of operations you took? You took one operation here, then two operation, then three operation, then four operation, and then five operations. So after five operations actually, you were able to start off from a single letter and make it so sufficiently large that you were able to find S. And isn't that what we counteracted and what we tried to prove as an argument? Can I say that if you were not able to create even in five operations this particular string S, how will you create in more than this operations? You cannot. Because understand this very simply. If you created X 32 times and you were not able to find S in this, what essentially will happen after you do one more operation? After you do one more operation, essentially what will happen is you will create an X string which will have 64 A's. Now the argument is if you cannot or were not able to find S 25 times, as in 25 A's in this place, then will you be able to find that in the new X? No, because what is this X? It's basically the previous X, that is this 32 times, and again repeatedly that 32 times. So if you were not able to find S over here, you cannot find S over here. So by this simple commonsensical logic, I can say that, okay, fine. If I do 5 operations at max in this case, after that it's futile. If I'm not able to find even after 5 operations, the string S in the string X, then I can simply say the answer is not possible to find. I can simply say I am going to return -1. Why -1? Because we can read this in the question in the output over here that if you are able to get a minimum number of operations, print that. But if it's not possible, actually output -1. So basically I know if after 5 operations I still am not able to get S in X back, I will simply print a -1. Okay, so this is the whole logics behind the problem. Let us try to look at the code piece and understand how can I implement this in brute manner. Okay, so we'll go to our code, and what I've done over here is I've taken up my main function. I've created actually a checker function for me. We'll come to what is this checker function for me. Again, implementation difference can be a bit different for your case. For my case, the logic should remain same. Okay, so what I've done is I've taken the input of T, that's the test case variable. Then I have taken the input of NM and the X and S string. So this is up till here only taking inputs. Now I am taking 5 different, or exactly 6 different strings. Alright, one string is X0, X1, X2, X3, X4, X5. What is the actual abbreviation meaning of this? X0 simply means you have done 0 operations. What is the meaning of X1? This is after doing 1 operation. What is the meaning of this? After doing 2 operations. This is of course 3 operations. This is of course 4 operations. And this is of course 5 operations. So if you look very carefully, what is X1 actually? X1 is the string concatenated from X0 onto itself. Then X2 is made from X1 concatenated to itself, because I know that the actual string X has modified. So I had initially stored X to X0. Now X0 got X0's concatenation, and then X1, that was actually the new string, again got concatenated to create X2. X2 got concatenated to itself to create X3, X3 to X3 to create X4, and X4 to itself to create X5. So these are basically my 6 possible strings that I am creating after 0, 1, 2, 3, 4 and 5 number of operations. Now these are the 6 strings I want to actually check whether S is possible or not. So what I'll do is my initial answer is -1, that is assuming I never find an answer, and then I will simply run this if and else checks over here. This check is going to be first to pass whether I was able to find S in X0, whether I was able to find S in X1, in X2, in X3, in X4 and X5. And corresponding to that part, I basically have written else and else if checks, if and else if checks, to make my answer the least possible value. So if you are able to find your answer with X0, you say answer is 0. If you're able to find your answer with X1, next possible answer is 1. Then the next possible answer is 2. Then the next possible answer to be checked is 3, then 4 and then 5. And if you are never able to find answer anywhere in this if and else blocks, then answer will still remain -1 and you would have printed -1 as your answer. Alright, so it's just a sort of a different sort of an implementation I've done to showcase function handling also for the beginners. Again, you can of course do this with 2 for loops, 3 for loops directly over here. Not 3 exactly, 2 for loops directly over here, or without this function thing. I just wanted to better the code out, so that part considered. Now, if we look at the check function, what is it going to do? It's basically returning me true and false whether I simply feel x to be to be part of x. Now, how do I do that? Very first simple check. If x's size is less than s size, then I return false, because I know if the size of the string in which I want to check is even less than the string I want to check in, I can never find that string. I will return false. Else, this is basically running 2 for loops in a very brute manner. I run this from 0 to x size minus s size plus 1. So this is basically saying I want to chop off segments of s dot size in the x size. So basically, if I try to depict this in picture format, you can say that if let's say I have a string s over here given, and then let's say I have a string s of let's say assumably let's say of this much size, then I want to check this size, then 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 this size. So it's basically kind of sliding the window over here to actually check whether my substring is able to match or not, whether my each and every segment of s size is able to match or not. That's what I'm trying to do. So I will run one for loop, that is from 0 to the last iteration would be to x dot size minus s dot size plus 1. And then the other inside for loop would actually be not sort of a for loop. I can directly call the substring function. I can extract that segment string starting from I with a limit of s dot size, as in start from I and total want a s dot size length to be extracted. And if this net substring which I take out together is actually equal to the initial string s, then I will return true. And if no condition fulfills itself, then I will return a false. Okay, so now of course this is going to return a true only and only if any place of segment in x actually contains s, else it does not do that. Alright, so I hope the implementation has become clear. Again, this can be done a bit more with pen and copy, where you can actually jot down your pointers and understand this movement of segment, which would be much more beneficial to understand the inner implementation of how we run this simple check of checking whether s was present in x or not. Okay. So now what about the time complexity for this part? Of course, we are having, let's say we can discuss the time complexity of this function separately, and then we'll see what extra are we checking. So I have a time complexity, I have basically a checker function over here. This checker function is going to run in order of, you have n order over here, or basically n minus m plus 1 order over here. And then you can say this is the substring function, which is obviously going to run in m order. Why? M is the size of the string s. So you take out m sized string from x and you check that with the string s. So this is m order. Basically, if I write the final order of this checker function, this can be O of, this is n plus m, n minus m plus 1 into m, right? And you can just open that bracket, and this is going to be O of n into m minus m into m plus 1, right? Plus 1 or plus 1 into m, plus m, where it would be more obvious that we can just boil this complexity down to a order of 2, where I can take n into m to be better time complexity. So generally, like, you can write this as n into m only, right, as a checker function. Basically dependent length on what you pass over here in the string s and what you pass over here in the string x. Just multiply both their lengths, and this is the rough order that would come out for this string s. Now if we actually want to go deep into that and even further into that, we can actually see that, okay, if I have total 5 operations at max which I can do, that means I would be more bothered with this set of piece over here, that is actually if I have taken the x size string, that is 5 operations. So taking again our main case back, that is if let's say n was 1 and m was 25, you can say that the maximum lengthed string you would actually go would be in 2 power 5, order, correct? Because we are creating a total, we created a total size of 32 over here. That was X. And in that string size, we tried to find this. So approximately I can see that when I pass this for X5 in this checker function, this would become 32. And that is the n string, n lengthed, that's the X, and S is still going to be 25. So approximately I can write this time complexity to be in O of 2 power 5 into n into m. And now this approximately would be O of this is 32 into n into m, 32 into n into m. And did we discuss as the expected time complexity, I don't want to go above an order of 100 into n into m, which is very, very clear. I am not going above that. This is basically just 32 into n into m. Going to work gives us the right solution. And what about the space complexity? So if I write this space down, I can see that I am using some extra space to actually store these strings. Now the size of the X string is n, and then maximum you are doing 5 operations to create the largest strings, that's X5. So if I count actually X5 into picture, what is actually happening? Can I say that X5 is getting total size multiplied by 2 power 5 in the same way we actually calculated time complexity, that's 2 power 5. We can see that since I'm concatenating X over so on 5 times, so basically the size is increasing. It's going to a limit where it finally gets multiplied by 2 power 5. That would be the size of X5. And since I know I am bothered with the largest space stored, that is the worst space, you can say, in terms of how we also calculate time complexity, same way in space, the worst space would be actually, you can say, O of 2 power 5 into n. And this is again going to be something like O of 32 into n. And if we just remove this constant factor of 32, then we can report this as O of n only, but we can just keep it like here also. O of 32 into n is also fine. So this space again is good to go. I have been given enough space in my question so that this definitely fits. And time complexity, as we discussed, are expected wise. This of course fits. I am within my boundary. Does not get me a TLE, and it gets me an accepted solution. Alright, so I think for a fun problem, this is majorly a very implementative based problem. The main catch was to understand that what is the highest limit I can go. If we get that part, then creating a time complexity in our head and reworking with this solution of checking whether S is present in X or not by any method suitable to you. Again, I use some sort of a substring method. You could have used some other function or some other library in that case. That's totally up to you. But the implementation is a different part. The understanding of this being a very brute solution was the main trick behind the problem. So I hope you liked the video. Thank you for watching.